Audible? Can you hear me, guys? Thank you. Thank you. Cool. Just give me 1 second. I'm just trying to pull up my lab. All right. So let me start with sharing my screen. Hopefully you guys can see my screen. Hello, everyone. Thank you for joining the session today. Today, we are going to have a brief discussion about Prometheus, right? We are going to talk a little bit about Prometheus and how do we use it for monitoring, right? It's a very high level discussion. I'm going to talk a little bit about what is monitoring, what is expected from monitoring, and then why does Prometheus exist and why do we use it? Okay, let's talk a little bit about monitoring. What is monitoring and why do we use it? So when you are an application developer or someone who maintains an application, right, operates an application, you are very concerned with the behavior of the application because the behavior of application directly impacts the customer's experience, right? So let's say you are a developer, right, or you are an ops engineer, right? Whoever, whatever is your role. If you deploy an app, some app somewhere, right? If you deploy an app, uh, and then your end user, your customers are interacting with this application, right? Let's say it's a web application. Interacting with the application, they are, let's say if it is an e-commerce application, they are adding items to the cart, they're browsing the catalog, they're ordering, making payments, blah, blah, blah. If the application is not stable and if it is not behaving in an expected manner, the experience of the customer will not be nice, right? Now, why would an application not behave correctly? So there could be bugs which will prevent the application from working correctly, like maybe some code is not written well, or some functions are not defined, or there's a dependency which is not satisfied, database is not reachable, blah, blah, blah. Right. So there could be some bugs which can govern the behavior of this application, or there could be infrastructure issues, right? There could be infra issues. So for example, there are not enough CPU to handle the incoming requests or RAM to handle incoming requests. There is not enough storage available on the database to store further data. There is not available network bandwidth to enable communication between various components of the application and the database and the cache and whatever, right? So now customer will experience this application behavior and may choose to move away from the application or go away from the application, and that would immediately result in a business loss. So how, as an organization, how would you make sure that you catch these behavioral problem of your application as soon as possible, right? No application is bug free. No application can guarantee that infrastructure is never going to be down or never going to be compromised. But how do you minimize that? You minimize that by monitoring that particular application, right? You would like to have a bird's eye view. I'm just trying to draw an eye here. So you would like to have a view of your application and would like to view the application as if you are the customer, right? And more. So you will want to make sure that I would like to monitor what is the CPU utilization of the app, what is the RAM utilization of the app, what is the utilization of the entire system, the VM or Kubernetes cluster or whatever, wherever it is running, what is the system resource utilization, right? And then maybe some application performance, like how many error 400s are being returned, how many error 500s are being returned, how many successful authentication are being returned, right? So some sort of these errors, what is the performance of the database? So you would like to have a system where you can see these particular metrics about your application. And then if you find something out of place or something which is not expected, then you can take some actions, right? For example, if you're monitoring your application and you find out that the CPU is utilized more than 60, 70%, the CPU utilization is 70%. 70% CPU is utilized, your application is needing it. If there is any spike in customer requests, then the application may very well crash because there is no CPU left to handle that scale, right? So if you are monitoring your application, you identify that this is the case, then you can take some actions. For example, you can scale up or scale out your application, add more nodes behind your load balancer, or try to kill some processes or abandon old sessions, whatever you want to do. Okay, so you want to monitor, you want to capture the metrics, and then you want to perform some action based on the metrics. Okay, that's why you want to have monitoring. Now, how does Prometheus help in this? Okay, we are going to specifically talk about Prometheus. So Prometheus is a monitoring solution, right? So if you have your app, which is inside your, let's say, a VM or whatever, you would set up a Prometheus server which would gather the metrics from this app, from this VM and from this app as well, right? It would gather the metrics and then store the metrics in the Prometheus local storage. Okay. So for example, every 1 minute, Prometheus is going to talk to the application and find out what is the CPU utilization, what is the RAM utilization, how many incoming requests, how many outgoing requests, how many errors, how much storage, blah, blah, blah. All those metrics will be checked out and then they will be stored in a local database. Okay. And Prometheus may do it every 10 seconds or every 15 seconds or every 1 minute, whatever is configured. So Prometheus scrapes these metrics, right? It scrapes these metrics every X minutes or every X unit of time. I would just say seconds. Every X seconds, it scrapes the metrics from the targets. These are called targets. And then stores them into a database. This is a very special database known as time series database, right? That means the data that is stored is like snapshots. Snapshot at 12 p.m., snapshot at 12 p.m., 10 seconds, snapshot at 12 p.m., 20 seconds, right? Something like that. So this is where your metrics are stored, metrics storage, right? And then you can connect some external systems for further processing the metrics. Right? What do I mean by further processing? Maybe you want to create a dashboard, right? Maybe we want to send some alerts. So you can connect with the Prometheus server and then send some alerts if certain conditions are met, like CPU is 70%. Or you can create a dashboard which you can display in front of your team and say, hey, this is how the health of the application looks like. This is green, this is red, blah, blah, blah. Or you can maybe integrate it with some other systems to already create some tickets with IT. Right? So you can have further integrations. Prometheus' job is to scrape the metrics and store them in the database and make the metrics available to the subsequent consumers. Okay. Now, one thing which we need to know is what are these metrics that we are talking about? Who generates them? How are they generated? So the metrics are nothing but you know, so let me put it this way. Every application or a VM would have a HTTP endpoint. Okay, so if your application is running on, let's say, www.myapp.com, then there will be a service running, for example, /health, yeah, or /metrics or whatever. And if your code is written properly and code is generating metrics, then the metrics can be accessed at some HTTP endpoint. So every application's responsibility, and in turn, that means every developer's responsibility is to make sure that the application is exposing some metrics. And metrics are nothing but key value pairs. For example, the key can be CPU utilization, and value can be 45. RAM 3, value can be 1048 GB, for example, RAM free GB, right? Disk free GB. Let's say disk free GB is 200. So these are some metrics which can be exposed. There's a key, there's a value. The key should indicate what metric are we talking about here? What is the property that we are talking about here? And on the right side is the value, which tells what is the value of that property. For example, this metric will clearly say that the CPU utilization by this application is 45%. Right? So something like that. And the Prometheus scrapes these metrics and then stores them. Okay. Now let's quickly set this up, and then we can take a look at here, right? So let me see if my lab is up. Just give me a second. Give me a second, please. Looks like lab is actually not responding. I'm logging into my AWS account. We'll just run the lab there. Just give me a moment, please. Hmm. Looks like my account has been suspended for some reason. Okay, let me try a different one. Okay, I'm facing a bit of a challenge with my lab. Let me try one more thing. Yeah, it's not working out. Okay, let's try something on Windows itself. Okay, on my laptop. Let's see if this works. All right, so what I'm going to do is I couldn't get my AWS account up and running. I think there is some challenge there. What I'm going to do is I'm going to deploy a Prometheus application, right? And then show you how the metrics are scraped and then how the metrics are used and what are the different kinds of metrics that exist for any application. So this is the Prometheus website. This is the documentation route. And if you want to install Prometheus, you can just go to download here and then look for the binaries that you want to install or that you want to run. You can also run them as Docker images as well, right? So as Docker containers, you can run your Prometheus application. So if I click on the Docker thing, I can go here and I can find out that there is an image called from Prometheus, which I can run and have my Prometheus up and running, right? To run this application, it is pretty straightforward. You just pull the image and you do a Docker run for this image. There will be somewhere some documentation. Yeah, so here it is, Docker run, and you can run your application here. Okay, so I will try to use this, but before that, I am trying to set this up on Windows. Okay, so you can say if you have um, where is any architecture here. So for example, if it is FreeBSD or general Linux, for example, you can download this Linux, you can choose your architecture and then download the image and then run Prometheus from that particular binary. Okay, these are pre-built binaries. I'm going to go for Windows, so I'm going to download this one. So this is the release candidate, but this seems to be the latest binary. So I'll download this latest binary. I'll click on it. It's downloading, hopefully. Right, so let's browse to this. And this is my Prometheus binary. I'm going to extract it. Right, extract it here. It's just a zip file. And here is our Prometheus binary. Right? So you see here, there is, right. So there is, no, this view is not good. Right. So there is Prometheus.exe, and there is a configuration file called Prometheus.yaml. Okay. Let's open this in terminal or command prompt. Right. And what I'm going to do is I'm going to just run the command Prometheus.exe. And it starts a server. Okay. It says, do I want to allow this? Yes. Network communication should be allowed. It asks for my admin credentials. And perfect. Just by running the Prometheus.exe, it is working fine. If I go to my browser, this is my browser here. And if I go to localhost 9090, you see Prometheus exists. Right? There is a Prometheus. We don't have much here, but the application exists now. So the application is running. So what we have done now is we just started the Prometheus server. And for every Prometheus server, we would have a configuration file, a Prometheus configuration file, which is in YAML format. Okay. And in this configuration file, you define all the behavior properties for Prometheus. For example, you define a list of targets, right, which are scraped. So this is a target. You can scrape Prometheus itself. So Prometheus also exposes some metrics. So you can scrape itself, or you can set up some other systems like, for example, Jenkins. And then you can scrape metrics from there as well. So what you want to scrape is defined in the targets. Okay. If you want to send some alerts, you define them there. You define some configurations as well. Yeah, different configurations. So anything that you want to modify or add or configure in Prometheus has to be done in this YAML file. Right now, we are running with the default YAML file here. So let's go to the Prometheus server. And when you have the server, you can actually look at the configuration from the server itself. Okay. So if I go to status and if I say configuration, I can see what configuration is Prometheus running on. Okay. This is coming from the YAML file itself. YAML file is loaded into Prometheus and then it shows it here. So you can see all these things here. There are so many things. What I want to point to is scrape configs. Okay. Maybe I can show you the YAML file itself. So let's open it with, see if it finds Notepad++. It doesn't. So I'm just going to open VS Code. Right. So you see here, this is the Prometheus.yaml, right? And a lot of things are commented out because it also acts as documentation. What I'm going to talk about is scrape configs. Okay, scrape config defines what targets you want to scrape the metrics from, right? So there is a config called Prometheus, and it says that the target is localhost 9090. That means we want to scrape any metrics that is available on localhost 9090. Localhost 9090 is the Prometheus server itself. So if I say localhost 9090 and go to slash metrics, right? Localhost 9090 slash metrics. If I go here, you will see Prometheus itself is exposing a lot of metrics. So Prometheus as an application is exposing a lot of metrics here. So you see here uh, on this metrics endpoint, we can expect the metrics to be available, and Prometheus also exports here. So you see all these metrics here. So now coming back, my configuration says that Prometheus should be scraping the metrics at this URL, and the metrics path is slash metrics. The default metrics path is slash metrics. So it's going to look at localhost 9090 slash metrics, and it should be scraping the metrics from here. Okay. So what are the metrics? Before we even go and look what Prometheus has scraped, let's look at what are the metrics the application is publishing. So you can see here, there are some metrics like which one should I talk about? So hold on a sec. Right. So for example, this is a metric. Go GC heap freeze bytes total, right? So Go, the metrics is written in Golang, so it exposes some Go specific details also. And it says garbage collector, and it has freeze some byte from the garbage collector from the heap. How much was it freed? So this much bytes were freed when the last time it executed. Okay, maybe that's a bit confusing. Let's find something else. We have something for CPU. Yes. For example, process CPU seconds total. How much CPU has Prometheus utilized since it started running? Okay. So total user and system CPU time spent in seconds. So how much total CPU utilization has been done in seconds? Duration. It says 0.3 seconds CPU has been utilized by this application. Okay. So that's one metrics. Then how much virtual memory is Prometheus using? That's here. Then there could be how many requests? No, not this one. Total requests. Let's go. Yeah. How many total requests? So how many total requests have been made for this metrics endpoint? So it says Prometheus HTTP total request for with error code 200 at slash metrics. And the total request is 16. So maybe Prometheus is regularly talking at this endpoint. So total requests served are 16. Right? So, and the total requests at hold on a sec, localhost config, right? Slash config. Yes. So total requests at this particular endpoint / config endpoint, it says 0. Okay. The HTTP request served at / config endpoint is 0. But if I refresh this and I look for it again, it says one time there is a HTTP request. One HTTP request has been served. If I refresh this again, hopefully Prometheus metrics also reflects that. So it says, 3 times the / config is being returned. Okay. Similarly, if I just continue refreshing, hit this URL endpoint again and again, you will see that it again moves to 5. So it is a metrics that is being exported. So how many HTTP requests has been served on this endpoint? And it says 5. Right? So that's something that we are looking for. These are kind of metrics that we are looking for here. Now, if I go to Prometheus, right, and let's zoom out a bit, go to Prometheus homepage, and here I can query the same metric. Right? I can query the same metric here because all the metrics are being queried and are available here. So if I look for this metrics, now what Prometheus is doing is it's scraping the metrics, right? It is scraping the metrics and storing them in the database. Now it gives us a web UI which can take the data from the database and display it for you. So you see, it gives us a small UI. I say I want to see this metrics, and it shows me this here. Right? If I want to see, it shows me all the endpoints and all that. If I just want to see at this location, it tells me the value is 5. I can also see in a graphical manner. So it tells me that at 8:35 or something, it was 0, it was 1, then it became, it was 0, then it became 1, 5, and maybe later when it will check, it may increase also. So you can see this graph going up, right? So you can see how the application has been behaving historically. Am I making sense? Now, if there is an application running, you can, of course, change this configuration and add more scrape config. For example, let's say you have a, right, yeah. So let's say you have my app running somewhere, right? And you will say, well, look at www.myapp.com:80, for example. And then you can also say that the metrics path for this particular application is equal to /metrics, or if it's a different where your application is being serving, then you can say /help or whatever. If you add this configuration and restart Prometheus, then Prometheus will look at this particular URL /help and try to scrape metrics from there. Now, how frequently is the metric scraped? That is here in the global configuration. The scrape interval is default 15 seconds. That means every 15 seconds, Prometheus is going to talk to the target and try to scrape the targets there. If it fails, it will retry again in 15 seconds. Okay, you can configure this as well. You can say, I don't want 15 seconds. I want to have it at 1 minute for this. So you can define that configuration for each target also. But we can live with 15 seconds, right? Or maybe I can change it to 5 seconds. Just like that, just for fun. So we go back, we stop the service, and then we start the service again. So I will go here and I refresh. And if I go to status and configuration, you will see that in the configuration, let me zoom in, there is Prometheus and a lot of default values which have been automatically filled up by Prometheus. And then there is my app, right? Matrix path is /health and a lot of default values. And we can also see the targets, the health of the targets. And you see here, it says Prometheus is up, but this is down because it's not a real URL. It says no such hosts, right? So in the targets, you can see what are the scraping targets and what is their health. Right? So it is as simple as that. Now, Prometheus can only scrape the metrics. It cannot generate the metrics for you. So it is the responsibility of the application to generate the metrics. So if you write something called as my app, you have to generate those metrics. So how do you generate those metrics? For an application to generate the metrics, right? It has to be integrated in the code. In the application code itself, you have to write all the code for generating the metrics. And this approach is called instrumentation. Okay, what is instrumentation? Instrumentation means in your application code, whatever code you are writing, you also add Prometheus relevant code as well. So that whatever event happens in your application, the Prometheus metrics are generated. Now, how do you add this in your application? Well, Prometheus provides you excellent binaries or libraries. Prometheus instrumentation. Right. So if I look for instrumentation, you can say you can instrument. There is okay instrumenting, right? Client libraries. So Prometheus provides first-party libraries for Go, Java, Python, Ruby, and Rust. These are the libraries that are developed and provided by Prometheus. So you can simply go to Python libraries. You can look at the Python libraries and you can just include the libraries in your code. And for example, you see this code here, right? You include the Python library. And whenever some processing happens, right? Let's say this is some processing has happened. You add your instrumentation code. You say, hey, I'm going to expose a request time metric. And the value for request time metric is some value here. Okay. And if I just run this Python script, it is going to run the server at port 8000 and I can see some metrics. Okay, so when you have a real application, you can include the libraries and develop a web app like that. So instrumenting is basic requirement for your monitoring to work. Right. Now you must have heard of tools called Grafana. I'm not sure if you have heard or not, but Grafana and various other tools are used for visualization. So you can visualize the data that is scraped by Prometheus, right? You can create very nice looking dashboards, like different panes here, here, right? Some pie chart here or something like that. In this, you can say over the time, how many HTTP requests are being served, how many errors we are seeing every day, right? Um, and how many artifacts are being served here. So some sort of graphs and data you can create. And Prometheus does not provide that, but Grafana can connect to your Prometheus database, and then you can run the queries, complicated queries, get the data from the database, and create some very nice looking, detailed, interesting dashboards. Did I make sense? So before we wrap up, I will also talk about different kinds of metrics. So there are few kinds of metrics. When you look at metrics, they have a type associated with it, right? First is gauge. A gauge is a metric type which can either go up or can go down, right? For example, um, current free memory, right? Sometimes it could be 50, sometimes it could be 70, sometimes it could be 40. So depending on what state your application is, the value can go up and down. And for such values, you generally show them as graph, like line graph or histograms. There are some metrics which are counters. Counters always go up. For example, total HTTP requests. How many total HTTP requests has been served by this application? It cannot go down. If it is 40 right now and there are more requests served, it will become 41, 42, 49, like that. It will never come down from 40, right? Because it is a total, it's a sum. So it is always going to be increasing. Like this. It's always going to be go up. It will never come down. Okay. So that's the counter. Third is summary. A summary is a special type of um, metric where it also shows you, it does some calculations for you based on the existing values and shows you them. For example, uh, if you say total HTTP requests, then you can find out how many requests were in the 99 percentile, how many requests were in 85 percentile, how many requests were in 80 percentile or 50 percentile, and things like that. So it's a special kind of uh, metric, and maybe when you deal with them more, you will understand them more a bit. But for now, it's just enough to understand that there is gauge and counter. And if you look at a metric, if you go to here, for example, each metric is associated with the documentation, right? So, for example, let's see, right? So there is a metric called process virtual memory bytes. So how many virtual memory bytes are being consumed by this process? Okay. For each matrix, there is a help. So process virtual memory bytes, virtual memory size in bytes. So some help text like what is this matrix about? And then what is the type of this matrix? The type is gauge. That means it can go up, it can come down. Right now, the value is this. Right? So if I maybe look at this value in my Prometheus here and graph, you can see this value has been going up and sometimes comes down as well. Maybe I restarted my Prometheus here, so it came down. Then it went back up, right? So there's always going up, down. thing happening. Overall, I see the trend is that the memory utilization is going up, right? So each matrix has a help and then a type and then its value, right? There will be some counters. For example, if I look for this matrix is a counter of HTTP requests. This value is always going to up. It is never going to be coming down, right? I think because we restarted, it went back to 0. But yeah, if the service is long running, it will never come back down. Right. Questions. So I can take some questions and then we can wrap it up. Grafana is like Tableau. I can say yes, it is like Tableau. You are right. Tableau is a bit more um, powerful tool. It's mostly done for business automations. But you can draw that analogy, yes. How to add this to Grafana? I'm not sure. Let's see if I can quickly show you that. We have Grafana for Windows. Standalone binaries. Let's do this. Let me see if I can run. Any plan of PromQL session? Yeah, we can do that soon. Yeah. Can you please explain your query page? You have mentioned usage bytes, how you pull it. Okay, so we need to know this one. You are saying that this query page or the metrics page? Yeah, so metrics is you need to know where your application is exposing the metrics. Generally, it is the application URL / metrics. You will see the metrics exposed here. So that's mostly it. Let me open the Grafana binary. Let's extract it. Oh no, there seem to be so many items here. Wow, it's going to take some time. The idea is once you have Grafana up, then you can go to the configuration and connect your Grafana to talk to the Prometheus and get the data from there. See if we can quickly get it. How to import any pre-built dashboard? That's very easy. Let me show you. Okay. We still have few minutes. Does Prometheus integrate scrape from /health endpoint provided by a Spring Boot application? Generally, /health endpoint is about the application health. Yeah, those are not metrics. Those are maybe, you know, the /health could be a API endpoint which serves data and returns data in JSON format or YAML format or something. So we don't have that. If it is actual metrics, then Prometheus can scrape it, but I think it is not. I don't know if it is actually metrics or not, but if it is metrics, yeah, Prometheus can handle it. What is data source proxy in Grafana? Grafana is not, that's taking time. Data source proxy, Grafana. Let's see what you're talking about. Are you talking about connection proxy or are you talking about general data source? So when you have a, let's see, where is Prometheus? Yes. So when you have a Grafana installed, yeah, you can see a dashboard, something like this. I don't know if there is any Grafana dashboard examples. Yeah, maybe this is a good place to start. So you can create dashboards like this. And for example, you can see very nice looking this dashboard, right? It is monitoring Kubernetes. So you can see how many clusters are there, how many nodes are there, how many namespaces, workloads, pods, containers, blah, blah, blah. And you can see how much resource utilization, memory usage by cluster, CPU usage by cluster. So all kind of detailed dashboards can be created. So Grafana enables you to do that. Now, this is coming from a source, and most probably this is coming from Prometheus. Okay, so you need to, whenever you have Grafana, you say, hey, connect to Prometheus. Here is my Prometheus URL. Get that information from Prometheus time series database, and then use that to run my queries and create this dashboard. Right? So a data source means where is the data coming for display in Grafana. Right? A data source could be a database. A data source is Prometheus. A data source could be an Excel as well. Sometimes data source could be Event Manager, AWS Event Manager, or it could be various other data sources, right? For example, I can show you uh, data sources, right? So you have many data sources. So there is Alert Manager, there is Prometheus, right? There is PostgreSQL or MySQL or Elasticsearch or Azure Monitor, CloudWatch, whatever some sources, many sources can be added here. Okay. So I'm not sure if I answered it correctly or to your satisfaction, but yeah, that is something. This is crazy. This unzip is crazy, man. And if you want to import an existing dashboard, you can go to something called as Grafana dashboards, right? So for example, this is a page called Grafana dashboards where you can see people who have already created some dashboards, right? And you can just import them. So if I go to Prometheus, let's say, there is nothing here. But if I'm managing Kubernetes, right? Or let's say, yeah, Kubernetes. right? So there is this, somebody has created a Kubernetes dashboard here, right? It gives you a lot of information about Kubernetes cluster. Now, if you want to just steal this dashboard, which is not stealing, it's just like importing, then you can copy the ID of the dashboard. The ID is 15611, 15661, sorry, and then import into Grafana. It's straightforward. You can just go to import section and then import in Grafana. So that's pretty straightforward. Or you can download this complete JSON for the dashboard and then import it in Grafana. It's all JSON based configuration, I guess. So it's pretty straightforward. Unfortunately, this did not come up for me in time. And I did not intend to cover Grafana in this session. Maybe I need to create a separate session altogether for Grafana to understand how we can create nice looking dashboards. Maybe the next session could be about it. All right. So thank you very much. Thank you for the time. And I hope you enjoyed the session. I hope it was enriching and it added some value to your time. Thank you. Take care. Enjoy the week. Bye bye.